you have learned what is limit and how to find limit by using intuitive method and basic properties. At the end of lesson, you should be able to find limit fx as x approaches c over limit gx as x approaches c when limit fx as x approaches c equal to 0 and limit gx as x approaches c equal to 0. As you have learned in lecture 1, limit for the rational function can be found by substitution method when the denominator does not equal to 0. The second type of rational function is when we substitute x equal to c into the function, we get 0 over 0. This is called indeterminate form. This function is undefined when x equal to c, but its limit may exist. Then we use either factorization method or multiplication of conjugates method. For factorization method, we have two steps to find limit. First step is factorize the numerator and denominator or either one. The second step is simplify the common factor. Example 1. Find limit x squared minus 9 over x minus 3 as x approaches 3. When we substitute x equal to 3 into the function, we get 0 over 0. How to solve this? Okay, to solve this, we will factorize x squared minus 9. This becomes limit x squared minus 9 can be factorized as x minus 3 x plus 3 and over x minus 3 as x approaches 3. We can cancel out x minus 3. This becomes limit x plus 3 as x approaches 3. Then we substitute x equal to 3. This is 3 plus 3 and then the answer is 6. For example B, find limit x squared minus x minus 6 over 3 minus x as x approaches 3. When we substitute x equal to 3 into this function, we get 0 over 0. Now we factorize numerator as limit x minus 3 times x plus 2 over 3 minus x as x approaches 3. We have x minus 3 for the numerator and 3 minus x for the denominator. We cannot cancel it. We must factor out negative here. Limit negative 3 minus x times x plus 2 over 3 minus x as x approaches 3. Now we can cancel out 3 minus x. This becomes limit negative x plus 2 as x approaches 3. When we substitute x equal to 3, here is negative 3 plus 2 and then the answer is negative 5. Example C. Limit x cubed minus 8 over x squared minus 4 as x approaches 2. This is also 0 over 0 when we substitute x equal to 2. For the numerator, to factorize cubic function, find one of the zeros for the function. And 2 is the 0. Here is x minus 2 is a factor for the function. Use long division to get other factors. Here is x cubed plus 0x squared plus 0x minus 8 divided by x minus 2. X cubed divided by x is x squared. X squared times x is x cubed. x squared times negative 2x squared minus 0. This is 2x squared. 2x squared divided by x is 2x. 2x times x is 2x squared. 2x times negative 2 is negative 4x. Okay, minus 0. This is 4x minus 8. 4x divided by x is 4. Here is 4x minus 8. Now this limit becomes limit x minus 2 times x squared plus 2x plus 4 divided by x squared minus 4 can be factorized as x minus 2x plus 2. X approaches 2. Now we can cancel out x minus 2. This becomes limit x squared plus 2x plus 4 divided by x plus 2. X approaches 2. Okay, and then substitute x equal to 2 into the function. This is 2 squared plus 2 times 2 plus 4 divided by 2 plus 2. The answer is 3. Example D. Limit e power 2x minus 1 over e power x minus 1 as x approaches 0. We get 0 over 0 when we substitute x equal to 0. Okay, now look at the numerator. E power 2x minus 1. This is e power x squared minus 1 squared. This can be factorized as e power x minus 1, e power x plus 1. This becomes limit e power x minus 1 times e power x plus 1 over e power x minus 1 as x approaches 0. We cancel out e power x minus 1. This becomes limit e power x plus 1 as x approaches 0. And then substitute x equal to 0, e power 0 plus 1. This is 2. Now we look at this example. If ft equal to 2t squared plus 1, determine the value of limit ft minus f2 over t minus 2 as t approaches 2. First substitute ft is 2t squared plus 1 minus f2 is 2 times 2 squared plus 1 over t minus 2 as t approaches 2. Okay, here is 2t squared plus 1 minus 9 over t minus 2 as t approaches 2. This is limit 2t squared minus 8 over t minus 2 as t approaches 2. And then we can factor out 2. Here is t squared minus 4 over t minus 2 as t approaches 2. And then we can factorize t squared minus 4 is t minus 2, t plus 2 over t minus 2 as t approaches 2. We can cancel out t minus 2. Here is limit 2 times t plus 2 as t approaches 2. And then substitute t equal to 2 here, and the answer is 8. So far we have covered the factorization method. Now we will cover the conjugate multiplication. when the rational function is 0 over 0 for the function related to the set. First, multiply both numerator and denominator by the conjugate of numerator or denominator, and then simplify the fraction. Okay, example 3. Limit set 2 plus x minus 1 over x plus 1 as x approaches negative 1. We get 0 over 0 when we substitute x equal to negative 1. Now we will multiply by the conjugate. Okay, the conjugate is set 2 plus x plus 1 over set 2 plus x plus 1. X approaches negative 1. Okay. Multiply set 2 plus x times set 2 plus x is 2 plus x. Negative 1 times positive 1 is negative 1 over x plus 1 times set 2 plus x plus 1 as x approaches negative 1. Here is limit x plus 1 over x plus 1 times set 2 plus x plus 1 as x approaches negative 1. And then cancel out x plus 1. Here is limit 1 over set 2 plus x plus 1 as x approaches negative 1, and then substitute x equal to negative 1. Here is 1 over set 2 minus 1 plus 1, and the answer is 1 over 2. For this example, we get 0 over 0 when we substitute x equal to 2. Okay, to solve this, we will multiply by the conjugate for the denominator. The conjugate is set x plus 2 plus 2 over set x plus 2 plus 2 as x approaches 2. Okay, for the numerator, here is x minus 2 times set x plus 2 plus 2. And then we will expand the denominator. Set x plus 2 times set x plus 2 is x plus 2. Negative 2 times positive 2 is negative 4. As x approaches 2, here is limit x minus 2 times set x plus 2 plus 2 over x minus 2 as x approaches 2. Okay, cancel out x minus 2. Here is limit set x plus 2 plus 2 as x approaches 2. And then substitute x equal to 2. Here is set 2 plus 2 plus 2. And then the answer is 4. For this example, we also get 0 over 0 when we substitute x equal to 1. To solve this, we will multiply by the conjugate for the denominator. Okay, the conjugate is set x plus 1 over set x plus 1 as x approaches 1. Okay, for the numerator, here is x minus 1 times set x plus 1 over expand the denominator. Here is 2 times set x is x. Negative 1 times positive 1 is negative 1 as x approaches 1. And then cancel x minus 1. Here is limit set x plus 1 over 2 as x approaches 1. And then substitute x equal to 1. Here is set 1 plus 1 over 2. And then the answer is 1. Here are the answer for this exercise. At the end of lesson, you should be able to find one-sided limits and determine the existence of the limit of a function. We will start with one-sided limits. Now we look at the graph below. This is the graph for fx equal to x squared minus 9 over x minus 3. We can find the left-hand limit and right-hand limit from the graph. For left-hand limit, limit fx as x approaches 3 from left equal to 6. How to find the value of 6 here? Look at the graph before 3. Before x equal to 3, this graph when x equal to negative 3, y equal to 0. When x equal to 0, y equal to 3. Now, x getting closer to 3 from left. Y is approaching 6. And then look at the graph at the right, x equal to 3 here. When x approaching 3 from the right, y approaching 6. And then limit fx as x approaches 3 from right equal to 6. For one-sided limit, we may have left-hand limit or right-hand limit. For the left-hand limit, it is written as limit fx as x approaches a from the left equal to m. For the right-hand limit, it is written as limit fx as x approaches a from the right equal to l. We use negative for the left-hand limit and positive for the right-hand limit. For example 1, find limit x minus 2 as x approaches 3 from the right. Here is 3 minus 2 equal to 1. Okay, for limit x minus 2 as x approaches 3 from the left, here is 3 minus 2. This is equal to 1. Next is existence of limits. Limit exists if and only if limit fx as x approaches a from the left equal to limit fx as x approaches a from the right. If we have limit fx as x approaches a from the left equal to L and limit fx as x approaches a from the right equal to L. Therefore, limit fx as x approaches a equal to L. For example, if fx equal to 3x squared minus 1, find the left hand and right hand limit of f at x equal to 4 and hence determine limit 3x squared minus 1 as x approaches 4. For the left hand limit, limit 3x squared minus 1 as x approaches 4 from the left is equal to 3x squared is 4x squared. Substitute x equal to 4. 4x squared minus 1. This is equal to 47. For the right hand limit, here is limit 3x squared minus 1 as x approaches 4 from the right is equal to 3 times the value of x is 4. Substitute 4 squared minus 1 is equal to 47. Okay, limit fx as x approaches 4 from the left is equal to limit fx as x approaches 4 from the right. Therefore, limit fx as x approaches 4 equal to 47. Apart from calculation, we can find limit for the function from a graph. Now look at example 3. Use the graph below to estimate each limit at x equal to -1, 0, 2, and 4. Now look at the graph at x equal to -1. negative 1 is here. We have the same graph for the left negative 1 and right negative 1. Here is the graph. This graph shows that y equal to 1 from the left negative 1 and the right negative 1. Therefore, for x equal to negative 1, limit fx as x approaches negative 1 equal to the value of y is 1. For x equal to 0, 0 is here, and then the graph at the left 0 is here, and then the right 0 is here. When x approaches 0 from the left here, the value of y is 1. And then when x approaches 0 from the right here, the value of y is 1. Therefore, limit fx as x approaches 0 is equal to 1. For x equal to 2. Now look the graph at x equal to 2. Here is the graph at the left and here is the graph at the right. Find limit fx as x approaches 2 from left. Okay, when x approaches 2 from left, here y approaches 1. Here is 1. And for limit fx as x approaches 2 from right, when x approaches 2 from right, here y approaches 2. Here is 2. Limit fx as x approaches 2 from left not equal to limit fx as x approaches 2 from right. Therefore, limit fx as x approaches 2 does not exist. Okay, for x equal to 4. Now to the graph at x equal to 4. We have the same graph at the left and at the right. When x approaches 4 from left, y approaches 0. And when x approaches 4 from right, y approaches 0. Therefore, limit fx as x approaches 4 equal to 0. Example 4. The above diagram shows the graph of the function f. Find limit fx as x approaches 1. Okay, find limit fx as x approaches 1 from left. Now look at x equal to 1 here. As x approaches 1 from left, here from left, y approaches 0. Here is 0. Okay, and limit fx as x approaches 1 from right. Okay, as x approaches 1 from right, here y approaches 1. Here is 1. Okay, now limit fx as x approaches 1 from left not equal to limit fx as x approaches 1 from right. Therefore, limit fx as x approaches 1 is does not exist. Example B, find limit fx as x approaches 2. First, find limit fx as x approaches 2 from left. Look at the graph at x equal to 2. Here, when x approaches 2 from left, here y approaches 1. Here is 1. And for limit fx as x approaches 2 from right, when x approaches 2 from right, here y approaches 1. Here is 1. Okay, limit fx as x approaches 2 from left equal to limit fx as x approaches 2 from right. Therefore, limit fx as x approaches 2 equal to 1. For example C, limit fx as x approaches 3. First, find limit fx as x approaches 3 from left. When x approaches 3 from left, y approaches 2. Here is 2. And for limit fx as x approaches 3 from right, when x approaches 3 from right, y approaches 2. Here is 2. Okay, limit fx as x approaches 3 from left equal to limit fx as x approaches 3 from right. Therefore, limit fx as x approaches 3 equal to 2. Now we will look at the limit for piecewise function. Given hx equal to 4 minus x squared for x less than or equal to 1 and 2 plus x squared for x greater than 1. Find limit hx as x approaches 1. To look clearly, draw a line to separate these two functions. Put 1 here. At the left, the function is fx equal to 4 minus x squared. And then for the right, or for x greater than 1, the function is x equal to 2 plus x squared. Okay, now for limit hx as x approaches 1 for the left. Now, the function at the left is 4 minus x squared. Okay, here is substitute x equal to 1. This is 4 minus 1 squared. This is equal to 3. And then for the limit x approaches 1 from right, the function at the right is 2 plus x squared. This is equal to 2 plus 1 squared. This is equal to 3. Here, limit hx as x approaches 1 for the left equal to limit hx as x approaches 1 from the right. Therefore, the limit hx as x approaches 1 is equal to 3. For example B, given fx equal to 2 for x not equal to 1 and 5 for x equal to 1. Find limit fx as x approaches 1. This one means for x less than 1 and x greater than 1. Draw a line for x equal to 1 here, and then at the left the function fx is equal to 2. For x greater than 1 at the right, fx equal to 2. Now limit for x approaches 1 from left. The function at left is 2. Then the answer is 2. And limit for x approaches 1 from the right. The function at the right equal to 2. And then the answer is 2. Limit fx as x approaches 1 from left equal to limit fx as x approaches 1 from right. Therefore, limit fx as x approaches 1 equal to 2. For example 6. If fx equal to ax plus 3 for x less than or equal to 2, bx squared plus c for x greater than 2 less than or equal to 4, and 8 for x greater than 4. Determine the value of a, b, and c. Given that limit fx as x approaches 2 from the left equal to 5, limit fx as x approaches 2, and limit fx as x approaches 4 exist. First, draw a line to separate this function. Okay, here is 2 and then 4. Okay, for function x less than 2, here is fx equal to ax plus 3. For x greater than 2 less than 4, fx is bx squared plus c. And for x greater than 4, fx is 8. Okay, given limit fx as x approaches 2 from left equal to 5. Ax plus 3. Ax plus 3 equal to 5. Substitute x equal to 2. Here is 2a plus 3 equal to 5. And then a equal to 1. Since limit fx as x approaches 2 exists, this means limit fx as x approaches 2 from left equal to limit fx as x approaches 2 from right. Given limit fx as x approaches 2 from left is 5 equal to limit fx as x approaches 2 from right. The function at the right is bx squared plus c as x approaches 2 from right. Okay, here is 5 equal to, substitute x equal to 2. Here is b times 2 squared plus c. Therefore, 4b plus c equal to 5. This is the first equation. And since limit fx as x approaches 4 exists, this means limit fx as x approaches 4 from the left equal to limit fx as x approaches 4 from the right. Okay, and then function at the left 4 is bx squared plus c as approaches 4 from left equal to limit the function at the right is 8 as x approaches 4 from right. And then substitute x equal to 4. Here is b 4 squared plus c equal to limit 8 as x approaches 4 from the right is 8. Here is 16b plus c equal to 8. This is the second equation. Equation 2 minus equation 1. We get 12b equal to 3. And then b equal to 1 over 4. And then substitute b equal to 1 over 4 into equation 1. Here is 4 times b 1 over 4 plus c equal to 5. Here is c equal to 4. Now we look at the limit for absolute values. Find the limit if exists. Limit modulus x minus 3 as x approaches 3. First, we define modulus x minus 3 as x minus 3 for x minus 3 greater than or equal to 0 and negative x minus 3 for x minus 3 less than 0. Then here simplify x minus 3 for x greater than or equal to 3 and negative x minus 3 for x less than 3. Okay, draw a line to separate these two functions. 3 here and then function for the left here is fx equal to negative x minus 3 and then for the right here is fx equal to x minus 3. Okay, for the left hand limit, here is limit x approaches 3 from left. The function at the left is negative x minus 3. Okay, substitute x equal to 3. Here is negative 3 minus 3 equal to 0. And then for the right hand limit, x approaches 3 from the right. The function at the right is x minus 3. And then substitute x equal to 3. Here is 3 minus 3. The answer is 0. Here is limit x approaches 3 from the left for modulus x minus 3 is equal to limit modulus x minus 3 as x approaches 3 from the right. Therefore, limit for the modulus x minus 3 as x approaches 3 is equal to 0. For example B, limit 3 times modulus x plus 1 over x plus 1 as x approaches negative 1. First, define the modulus x plus 1 as x plus 1 for x plus 1 greater than or equal to 0 and negative x plus 1 for x plus 1 less than 0. And here is x plus 1 for x greater than or equal to negative 1 and negative x plus 1 for x less than negative 1. Then draw a line to represent the piecewise function. Here is negative 1, and then function at the left is fx equal to negative x plus 1, and function at the right is fx equal to x plus 1. Okay, find the left hand limit. Here is limit for x approaches negative 1 from left. The function at the left is negative x plus 1. Here is 3 times negative x plus 1 over x plus 1. Okay, we can cancel x plus 1. Here is limit negative 3 as x approaches negative 1 from the left. And then the answer is negative 3. For the right hand limit, here is limit when x approaches negative 1 from the right. The function at the right is x plus 1. Here is 3 times x plus 1 over x plus 1. And then cancel out x plus 1. Here is limit 3 as x approaches negative 1 from the right. Then the answer is 3. Limit 3 times modulus x plus 1 over x plus 1 as x approaches negative 1 from left not equal to limit 3 times modulus x plus 1 over x plus 1 as x approaches negative 1 from the right. Therefore, limit 3 times modulus x plus 1 over x plus 1 as x approaches negative 1 does not exist. Example C. Limit x plus 3 times x plus 2 over modulus x plus 2 as x approaches 2. First, define the modulus x plus 2. Here is x plus 2 for x plus 2 greater than or equal to 0 and negative x plus 2 for x plus 2 less than 0. Here is x plus 2 for x greater than or equal to negative 2 and negative x plus 2 for x less than negative 2. And then draw a line to represent the piecewise function. Okay, function at the left is negative x plus 2 and at the right is x plus 2. Now look at x equal to 2. Here is x equal to 2. We have the same function at the left and at the right x equal to 2. Then find limit x plus 3 times x plus 2 over modulus x plus 2 at x equal to 2 is positive x plus 2 as x approaches 2. No need to find the left hand and right hand limit. Okay, and then we can cancel out x plus 2. Here is limit x plus 3 as x approaches 2. And then substitute x equal to 2. This is 2 plus 3 equal to 5. Here are the answer for this exercise.